This is a follow-up video to the one where I was finding exponential models for numerical data in table form, and then also for a verbal description of an exponential function. And now we are going to find a model for an exponential function, which is represented by graphs. So in this particular graph here, we have an increasing function, and so this is exponential growth. Whereas here, you can see, as we move from left to right, this function is decreasing. So this is exponential decline. And I'm going to go ahead and start with this model here, and I just need to find C and A for each of these functions. Okay, so C is given to us when we plug in 0 here. This a to the power of 0 is 1. So f of 0 is going to be C. So here we can see that C is 3, because if I plug in 0, I get 3 as an output. And here, if I plug in 0, I get 2 as an output. So we can see right from this information, I'm going to go ahead and stick with purple. We have that C is 3, and here we see that C is equal to 2. So now for each of these graphs, we just need to find A. And what we're going to do is notice that the other point that's given to us here, when you plug in 2 into your model, you're going to get 4.32. So our model, since we found C to be 3, is f of x equals 3 times a to the x. And it says if I plug in 2 for x, I get 4.32. So that means f of 2 is 3 times a squared, and f of 2 is just 4.32. So now all I have to do is solve this equation for a. And I can do that by taking the square root of both sides. But first I need to divide both sides by 3. And then I'm going to take the square root of both sides. And a has to be positive. So that just means that, okay, this cancels out. So I have a squared square root. Since a is positive, I know that's just equal to a. And then this is the square root of 4.32 over 3. And so then a is 1.2. So our model for this exponential function is f of x equals 3 times 1.2 to the power of x. Now to find this one, again, c equals 2. So our model is f of x equals 2 times a to the x. And if I plug in 3, I'm going to get 1.458. So f of 3 is 2 times a cubed, and f of 3 is 1.458. I'm going to divide both sides by 2. And that just gives me that a cubed equals 1.458 over 2. And now I'm going to take the cube root of both sides. And that just gives me a is equal to the cube root of 1.458 over 2. And if you look at your calculator, you get 0.9. So a is equal to 0.9. Now, notice that this a is greater than 1, and this a is less than 1. Your a has to be positive, right? But if it's greater than 1, then that just means that our function is an exponential growth. And if it's less, between 0 and 1, then you've got a decline. So that's exactly what we have here. So for this particular model, f of x equals 2 times 0.9 to the power of x. And you can write this, okay, 9.9 is just 9/10. So if I wanted to write this as with an a value greater than 1, I can just replace, right, because 0.9 is 9/10, right? And that is just 10/9 to the power of -1. So if I want to, I can replace this with 10/9 to the power of 1, -1, and I get 2 times 10/9 to the negative x. So both representations are accurate. But if you're just looking for A, I would go with the first one. Sometimes you'll see people want to emphasize the fact that the model is declining. So rather than writing a fraction, they put a value of A that's greater, and they put a negative to emphasize the fact that it's declining.